Welcome back, guys. Today I'll be doing truth table and binary operation. It is a Cape Mathematics 2018 past paper, question 1. Now, when we talk about negation, the symbol for negation is when we have this tilde. So if I have P to be true, then the negation of this would be F. And if I have this to be false, then the negation of this is true. So the negation is the opposite. We also have and or. And this is a symbol along with or. Here I have my symbol. So for P, I'll have true, true, false, false. Then for Q, I'll have true, false, true, false. So if I have two true for an AND gate, P and Q, I would have a true for two true. If I have a true and a false, then I'll have a false. If I have false and true, then I will have a false. And then if I have two false, then it will be a false. Now think about it. If I say and, it means both items have to be true in order for me to get a true. So since both statements are true, then automatically we can say it's a valid statement. But if one is false, then it's, even if one is still true, it's going to be automatically false when I combine them. So once one is false for an AND gate, then it will be false. But for or means one is either this or that. So P or Q. One statement is true, then I can say the conclusion is true. So if I have two true, then for OR gate, I will get a true. If I have a true false, because I have true or false, so once one is true, then I can say it's true for the OR. Same case here, I have false and I have a true, but it's an OR gate. So once one is true, then it is true. But both of these are false, so automatically it's false. So for the OR, once you have one being true, then you can say it's a true. But for AND gate, both statements have to be true in order for me to say it's true. Let's look at a question. This is a past paper question. Let P and Q be any two propositions. Complete the truth table below. So once again, we have true, true, false, false, true, false, true, false. Let's find the negation of this. So we're going to change the two T's to false. Negation is the opposite, so this would be false, false, and then the two false will become true. Same thing here, I'm going to negate this, so this T will become an F. This F will become a T, this T will become an F, and this F will become a T. Now I'm going to look at P or Q. For P or Q, don't confuse, we're not using this, but we're using these items, P or Q. So for P or Q, remember once you have one being true, then automatically it's true. So true, true, that will give me a true. True, false, that will give me a true. False, true, that will give me a true. And false, false, that will give me a false. So once one item is true for our gate, it will give me a true. Now, when we have this negation, then it means we're going to change this. So this is going to be false, 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 and then this will be true. Finally, we're going to do the negation of P and the negation of Q. Now remember, for AND, both items has to be true in order for it to be correct. So these two will be false, false, true will be false, true, false will be false, and true, true will be true. That's it. Hence, state whether the statements negation of P or Q and the negation of P and the negation of Q are logically equivalent. And let's look at it. This is a negation of P or Q, negation of P and Q, and as you can see, it is logically equivalent because they're the same values. So that's what you would have stated in this space here, that since both of them give you the same truth values, then that makes it equivalent. Here we have a binary operation question. It states a binary operation, we call the circle with the plus sign within O plus, is defined on the set of real numbers R, capital R, as A O plus B is equal to 2A plus 3B for all AB is in R. Now, we're calculating 5O plus 2, where 5 and 2 are real numbers. Now, looking at the binary operation, it means 5 represents A and 2 represents B. So using A O plus B is equal to 2A, or A is 5, so I replace A to be 5, and B is 2, so I replace here to be 2. So 2 5's 10, and 2 3 6. So 10 plus 6, that's 16. So the answer is 16. The next question, prove that O plus is closed in R. So the operation that was given, I am going to rewrite it. So I have A O plus B is equal to 2A plus 3B. Now, in the question, it states that A and B are real numbers. So it means that 2A is also a real number, since A and B are real numbers. So if I multiply it by 2, it's still a real number. And if I multiply B by 3, it still remains a real number. So if I add these two real numbers, so 2A plus 3B, it will still remain a real number. So 2A plus 3B is the sum of two real numbers. And the sum of two real numbers still gives me a real number. So I can conclude that the O plus is closed in R. Now, determine whether O plus is commutative. Commutative means that if I have A O plus B, it is the same as B O plus A. A O plus B was given to us already. A O plus B in the original question is given as 2A plus 3B. So the left hand side will remain as is. So A O plus B is 2A plus 3B. So if I change it to B O plus A, will it remain the same? B O plus B means I've changed the order. So it's now 2B. So I'll have 2B here plus 3A. Now after changing it, they're not looking the same. It's not exactly the same. It's not the same at all. So they're not equal. So if they're not exactly the same, then we have established that it's not commutative. So it's not equal, so therefore it's not commutative. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, you can leave a comment below.